Hi, this is Tom, and in this video we're going to look at square roots and radicals. Square roots and radicals. Now, many of us have probably seen these, but let's do a quick review. So, if I give you the square root of 9, then actually let me go back. Let's give it a definition. So if some number squared equals some other number, so we'll say if a squared equals the number b, then the square root of b is equal to a. And notice when we write this that the a no longer has the exponent. So you might think, well, that's kind of confusing. Let's try this. So for example, if I give you the square root of 9, then what you have to do is think about this. Can 9 be written as some number squared? And after you think about it for a bit, you realize that, oh, sure, if I write 9 as 3 squared, then look what we can do. Then, let's write it this way. And I'm going to show this intermediary step, and there's a reason for this. Then, the square root of 9 is equal to the same as the square root of 3 squared. So now we can say that the square root of 3 squared is very simply 3. Notice that both the square root, this piece here, or I should label this is called the radical. And again, the 2 is still an exponent. And notice that those are gone. Those are gone. So let's try another one. For example, what if I give you square root of 100? That's a big one. Well, what we'd think about is, can you take the number 100 and write it as some other number squared? And the answer is, if you write 100 as 10 squared, then you would say that 100 is a perfect square. So then the square root of 100 is equal to the square root of 10 squared. So now you can say that it's just 10. So numbers like 109, there's many others. These are called perfect squares. Perfect squares. 100 is a perfect square. 9 is a perfect square. In this case, since b is a squared, b is also a perfect square. Now, let's try something else. How about the square root of 9/16? Well, that's interesting. We've worked with 9 before, right up above. We haven't worked with 16. But let's think about this. If I have the number 9/16, can I write it as some fraction squared? And remember, you could think of it this way, or you could think about it, we saw this in our previous video, as something squared over another number squared. You can think about it either way. So if you can write it like either of these forms, then you've got it. Well, right up above we said that 9 was the same as 3 squared. And most of us are comfortable that 16 is the result of 4 times 4, or 4 squared. So you could think of 9/16 as 3 squared over 4 squared, or you could think of it as the fraction 3/4 squared. So then we would say that, oops, there we go. Then, let me undo my, and then we would say that the square root of 9/16 can be written as the perfect square of 3/4 squared. So the square root of 9/16 is 3/4. One last piece. And this is one that people find to be a little bit difficult. But try this. What is the square root of 2? Okay. In other words, what number squared would give me 2? Now, think about this for a while, but what you'll find is this. You'll find that there is no number. There is no such number. And you can put this into your calculator and it will give you what we call a decimal approximation, or you could write this as the square root of 2. The most simple way you can write the square root of 2 is what we call is the square root of 2. And if you write it this way, it's called an exact answer. I'm going to explain that again in a moment. Or you could say that the square root of 2 is, let me just check my calculator here briefly. If you use your calculator and find the square root of 2, what you'll find is you get, and I'm going to change my equal signs to these little wiggly and a wiggly equal sign, meaning approximately 1.414, and it goes on. My calculator displays 2135662, but if you had a larger display, this number would actually go on forever, and the pattern never repeats. And we call this a decimal approximation. So in algebra, most of the time it's easiest if you just use the exact answer, but occasionally you'll be asked for a decimal approximation. Okay. Now, since we're on the idea of radicals, let's take this one step further. So we talk about things being implied. When I talk about the square root of some number b, there's what's implied is a 2. And we don't write it, just like you've seen above. But I don't have to stop at taking square roots of numbers. We could also take what we call a cube root of a number. Or we could take a 4th root. And this can just continue on and on and on. And this number up here, the 2, even on the 2, 3, the 4, and so on, this is called the index. And I'll show you why you actually are prepared to use this. Let's try the number 64. So I'm going to start out with number 64, and I'm not going to write anything. So that means again that there's this implied 2 that goes down here. And what we said is to take the square root of a number is if you could take the number 64 and if you can write it as something squared, then you found the answer. Well, 64 is the same as 8 squared. So you could say that the square root, I'll write it this way, 8. So the square root of 64 is equal to 8 squared, so the result is 8. Now let's try something more. Let's try the cubed root of 64. Well, what this means is if we take the number 64, can we write it as some number raised to the 3rd power? And if you play, well, we know that, let's see, we start with 2 and we raise it to the third, that's 8. If we take 3 and we raise that to the third, that would be 27. So let's try 4. If we take 4, that'd be 4 times 4, that's 16. 16 times 4 is 64. There you go. So, in other words, what you can say is that the cubed root of 64 is equal to 4 cubed. So this is 4. Now, here's the reason why, oops, cube root. Here's the reason for this step, is notice the exponent and index match. This is the key. They have to match in order for you to take that root. Let's try one more example for 64. Let's go so far as to try the sixth root of 64. In other words, what you're looking for is, if you have the number 64, can you write it as some number raised to the 6th power? Well, let's start with 2. If you do, you go, this is a lot of 2's. Well, I'm going to have to write this out to keep track. 3, 4, 5, 6. All right, well, 2 times 2, this is going to be 4. And times another 2, it's going to give me a result of 8. Times another 2 is going to be 16. Times another 2, I'm going to get 32. And there it is. If I multiply by this last 2, I get 64. So you can say that 64 is the same as 2 to the 6th. So the 6th root of 64 is equal to, oops, the 6th root of 64 is equal to 2 raised to the 6th power. And again, index and exponent match. So we can answer this. And this is the radical and the exponent and the index. You can think of them all as canceling, and we're just left with 2. The 6th root of 64 is 2. And that is how you deal with square roots and radicals. Thanks for watching.